How's it going, everyone? Welcome. Juliet Gonzalez here again. Looking at the React Performance, which is a course taught by Steve Kinney, head front-end engineer at Temporal. This durable platform, this durable execution platform, pretty much like a Kubernetes, but to cover a specific business use case. This is an open source tool. I think this is quite interesting because it's now something that Vercel is used on their servers. It's powered by Temporal. And in today's video, we're gonna see is now this section of the escape hatches as a way to get myself familiar with this kind of concept, be able to describe them, and when you need to talk to not only team members or college, but also business people, PM, designers, and non-tech savvy, also shareholders, I can make all of this concept much more meaningful for them. So, on that topic, okay, because at the end of the day, especially if we're going to take a look at how you can write React components in the most performant way, you need to know is how React works behind the scenes. And that's one of the part of this course. First we'll look at the introduction, React rendering and how that works, is you're able to describe how that thing works. And anytime you are creating a component, you know what's going on behind the scenes. That'll be a great thing for you. And then we're going to look at reducing rendering, context, and suspense and transition. Again, we're going to briefly describe as the introduction here, as well as the React rendering, which is going quickly through the learn section from React Docs to the describing the UI, adding interactivity, managing a state as a way to, once you know how to create your React components, you want to know how to make them much more easy to maintain and to write, as well as how you can now scale them and when you need to do something that are outside of the React components, how to do that. So for example, looking at the escape hatches. And then we're going to actually put up practices, as all of this particularly is techniques that Steve Kinney actually show us for us. So good, because now, all right, the whole point of this is to first, at least in the introduction, is to understand what is the value proposition of performance. And that is something that you can apply to your life as well. It's much faster not doing things, prioritize things, than doing it. And there's some corollaries to that. So it is much faster to do things later than right now. And with that, because now even the React Docs, and when we combine that with Steve Kinney as a way to look at how can we now, especially as a developer, create these React components in the most performant ways. First, by following is also the recommendation from React, as well as some of the things that right now, in giving his experience, we can do. So first, look at the production build. Is this on development or this is on production? Then you take a look now at the render tree and the hierarchy, as well as your state. Start from there, and then let's see what is the catching strategy that they're using. So for example, with the Memoize, or use Memoize, how actually they are loading things on demand, or how are now loading things that don't need to load using the Suspense API. Okay, and if you're really in a pickle, how you can use the transition as a way to now make some of this rendering perform later. So the TLDR of this is As we're going to describe is how React rendering works as a way to understand how this thing actually makes sense, especially from the React perspective, and also from the developer perspective. Is like we need to know at the end of the day how React works, so then we can build some toolset that allows to identify is this that allows to build is this tool set when it comes to identify any of these performance issues, and from there we can now come up with some solutions, aka best practice. So this is pretty much like when you look at knot, it's pretty much like untying a big knot. So you started to pull the right threads, and then you apply the technique that you already know over and over and over, and this is something good because it works for small apps to big and large apps. So for that, that's one of the things I'm going to dedicate quite a bit. I'm going to be precise, short, and concise when it comes to describe is the React. As a way to now finally get into the escape hatches, and we can is take a look at this particular section, which is crucial, synchronizing with effects. Okay, so because now that we look at what React is, especially that allows us to describe is a UI component, and this is a JavaScript framework. So we look at how can we write our components using JavaScript functions, as well as how can we import components, export components, how can we make use of this markup language called JSX that allows to combine is the JavaScript aspect with JSX, because at the end of the day, React, what it's doing behind the scenes is creating elements using the React.create elements for us. So as a way to now connect the JavaScript world with the HTML, we use JSX with curly brackets. We also look at how can we render components conditional. How can we render conditional components? How can we now pass data through these components through the props? Okay. How can we render lists of components, and how important it is to use a key anytime you're going to render a list, because this is how you tell React, hey, I want you to keep track of this. I want you to now, when you're going to update these elements, okay, you can actually do that in the most performant way. Pretty much like you have a folder and all of these files. Okay, if you know what is in there, when someone move that or remove an element or reorder that, you know what's going on. So you know what's going on. We also look at how important it is to write our React components in a pure way. Why is that? Because it will help us to with some things. First, we can make these React components to work in any JavaScript environment. So for example, on the server, and we can make sure that anytime that this component receives this unique data, we are always can serve that content through millions of users. The other is the caching capability that we can have, because now we're using these built-in tools as a way to indicate to React, hey, I want you to now catch this, meaning I don't want you to compute this component. So this is actually something that allows you to save time. And last but not least is when you're going to pass down data through the render tree, you can safely stop the execution and resume that. So this render tree is part of the another section that we talk about, which is how React sees your components and they're using a tree, which is a data structure that comes from the computer science. This is a way of how you can organize data. Data, pretty much like that you can think of, like you have a fridge, you have a backpack, and in your fridge you store fish, ice cream, your backpack, tablet, iPhone, keyboard, map, even your bottle of water, you name it, okay? And each one of them serves to a specific purpose. So if you're storing your fish in your backpack, you can, but you're gonna be the smelly guy or gal in the room. It's like, oh my God, where do you come from? Where do you come from? From a dog? That kind of thing. So now with that, we're using this data structure like a tree. There are other data structures. So you have now array, you have a hash, you have a linked list. You also have is a double linked list, trees, tries, graph, ways to organize our data. Okay, so with those data structure in place, which is now what the render tree actually is using, once you understand that, you're not able to understand is how to optimize your React components, but also is how the data flow goes through this. And what we also have is the tree dependency, which is reusable code that you want to use across your app. And the whole point of this is to send only the bare minimum necessary codes that your React components needed for your React components. So on that topic, okay, we can now do what is next, which is adding interactivity. So once we know how to create these components, if we don't add in any interactivity, after all, this is just a plain JavaScript, a plain HTML. It's like writing HTML. So how can we add interactivity? We can connect to our event handlers to any of the event using the curly braces from JSX and pass a function to that. And this is how we can start into adding interactivity. And the others are when we need to actually show data to the users, how the state allows to do. And the state is this function or hook that React comes from, which allows us to store or remember data in our components. Why do we want to do that? Because anytime you evaluate your JavaScript functions, like in JavaScript, or in this case, anytime when React evaluate your React components, which is a JavaScript function, the way how that works is by, in JavaScript, you create a new branch execution context, it goes through line by line through your code, the thread of execution, as well as it now stores things, which is the function execution, variable execution, or function, variable, the lexical scope, all right, the function lexical scope as a way to store all of the things that you're going to add as you evaluate line after another, and then gone. So there is no way for storing thing inside of our function. So the way we can do that is by using something called a closure, which is a nice little bonus feature that JavaScript that allows us is to, when we return a function from another function, we can now have access from this function that we return the outer lexical scope. In other words, we can now have this backpack of variables where we can make use of our variables with this function. The TLDR of this is that this is the way of how now in the component we can remember things using state. And for that, when you want to receive some data, let's say from the user, as a way to look at your balance in your bank accounts app, the transaction history, the credit card, and that kind of thing. It's like, okay, this is now the way of how you can show this data. And when it comes to update that state, you use using a set of functions. And when you set that state or you update that state, now React pass through this rendering mechanism, which is the trigger, render, and commit phase. So the trigger says when this happened. So is this happening at the root element, or this was caused by a component or any of its components whose state changed? So then it go to the render phase, which is just a fancy name to say calling your React components, calling your functions. And if this happened at the root element, now it's going to create all of these elements using the create element function from the document. Or in this case from the React create elements. If it's not, if that was triggered by a component or during rendering, well, React will gonna call the component that calls that state update change. It's going to compute all of its props and event handlers, the state, and the kind of thing, store that information from the next phase, okay, and then now it's going to call all of the components. So after evaluate that function, you get is an JSX, and if that component contains more React components, it will continue to evaluate that until there is no more component in a recursive way. So then once you know this, okay, once React actually evaluate and create is this, when React evaluate all of its components and aka create the virtual DOM, which is a computer concept that represents is the ideal UI, and keep it synced with the real DOM. So when React now pass through the rendering phase and create the VDOM, React 16 has now something called React Fiber, which is our special objects that are added to the VDOM as a way to provide more useful information for that. So this VDOM, which was created at the after the rendering phase, now in the commit phase, okay, if this triggering was caused at the initial render, okay, or at the initial and in the root element, React what it's going to do is to now append all of these elements to the DOM. If this was caused by a re-render, so now React that create the VDOM or that update the VDOM, it will now has a previous version of the VDOM and then compare their difference. This is known as reconciliation phase. And then through the diffing algorithm or any reconciliation algorithm that they have, now it's going to apply the necessary DOM updates to the DOM. Once the browser detects that, it will going to show your screen, it will going to show the UI to yourself. And that's it. And this process is repeated over and 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 over for that. So that's quite interesting. That's very, very, very interesting. Because now that we are able to describe that, and also we can know what's going on and how we can think of our states as a snapshot on every render, okay? And they are, which is not synchronous, okay? So if you want to get this, the state value, the state value will be the state value of, yeah, the state updates the value in the next render. And you can think when you're working on the event handler, which is when you set the state, that React fix the states within the event handler's rendering. That's one of the reasons why that now React call this as, you can think of your state as a snapshot for every rendering, and they are not synchronous. Meaning you're gonna see the update values, you're gonna see the updated state value in the next render. That's great. That's interesting. That's cool. By the way, that's cool. Because with that approach, now we can look at how can we now update our state, or this thing that now React 16 and 18 allow us to, thanks to this new rendering engine called Fiber, or reconciliation engine, sorry, called Fiber. We can now allow us to queuing series of states updates, known as batching, as well as providing other features from that. Something that actually putting is here, because it allows concurring rendering features, prioritizations of updates, and the ability to pause use abort work as needed. So this is now one of the capabilities that this particular feature, the React, now allows to us. So because of that, okay, because of that, so now that we look at how these things work and how can we now update our object in a state, array in a state, the TLDR is that focus is on always returning a new state, and how you can make your state update consist when it comes to use objects, use a spread operator. When it comes to update your state object, use a spread operator for that. When it comes to update arrays in states, always is return is a new state. So for example, if you're going to add elements, you want to return is, or you want to set is a new array. If you want to add elements, let's say you want to actually add an element at the beginning or at the end of that array, for example, use a spread operator to pass that data in between. If you want to eliminate data from that, you can use the find element, and then from there is actually get that data. Okay, and yeah, exactly. It's actually get that data. All right. So you can use a find as a way to find that element, and you're gonna get is a new array without that element. That's something interesting. So for example, with the array here find, it will find that element. Okay. Oh, come on, for real. Really? Don't believe you. What is wrong? Okay. Okay, stop, stop. Hmm. Come on, man. What now? Hmm. Okay, I think this is more like okay. Yeah, but I think that's more of the of Mozilla. Ooh, oh my God. Yeah, Mozilla, man. Mozilla actually is winding and playing. But anyways, method to create a new array filled with elements that pass a test provided by a function. The filter, right? So hey, is this filter? Yep, you can use this filter for that. So for example, in our particular case, is using is when you're going to replace an element or removing an element, you use is the filter for that. Hey, so is this element is not here? Okay, give me all of the elements that are different here. So okay, there you got it. So filters, transforming with map, replacing items as well with map, and inserting into an array, for example, where you can indicate, hey, where would you want to add this element? You want to use this element to adding as a stack, so adding all of these elements at the top, all right? Or you can use adding to all of these elements at the bottom, right? Pretty much like a queue, okay? So this is now how you can start to work with this particular data structure. And when it comes now to managing your application, especially your state, as you want to describe more and more ambitious React components, it's important to look at how you can structure your state, how you can make your state update logic consist, and also how you can pass down data to distinct components. Why is that? Because this is now when you're going to create more, as I mentioned, scalable UI elements in your application. Pretty much like for data visualization, which is now the industry, where the industry is moving, you know, because it's in there that a lot of these people actually need to do that. So that's quite interesting. That's very, very, very interesting. Yeah, that's very, very, very interesting. Why is that? Because at the end of the day, most of this application that we build is just to satisfy that particular condition. It's to satisfy is their user for that. So yeah, yep, yep. So as we mentioned here, as we mentioned here, um, the idea here is that once we're able to see this, okay, and yeah, once we're able to see this, how can we do that? How can we scale that application? So on, so on and so forth. Okay. First, we need to look at how can we react to input with state. as a way when you are going to create your UI, taking or borrowing concept from the UI designers when they create all of this wireframe. So first, if you want to now create your UI, you're going to have a state that you want to generate view out of this. Okay, so first is to identify all the different visual state that this component will have. Determine what trigger those state updates, especially if you, because the vast majority of this component actually are being created. If you're going to create now new components, that's different, you know. That's something that you might to consider. So the other is that, well, for example, when you're starting to creating your components, and how you can determine or how you can think how your UI state updates, okay, or learn how to think your UI change with or as a state change, okay. Identify all the different visual element, identify all the different visual state, okay, which must come from a designer, or you talk about with the designer. Identify all the different visual state, then determine what triggered those state to update. Then represent is the state to then represent the use state to represent those states, avoid any non-essential state, and then you're going to connect the handlers with the state. So this is something interesting, because now with this particular mindset, which is now a more declarative way or how to think UI states, how to think UI state, how to think UI change as state change, right? And this is also now looking at how you can do that. And when it comes to actually creating your first React components, when you're starting to identify, for example, all different visual state, followed by what trigger those state change, whether it is computer or human interactions, okay, or computer or human inputs, okay. Computer inputs like rendering an element here, or rendering an image here, fetching data from the server. But in the human, you have typing or clicking or navigating to a URL, okay. So with that, then is when you're going to represent those states using the use state in memory, and then avoid any non-essential state. And then is when you're going to connect those states in the event handler. So the other is that, because now this is the declarative approach, as a way to create now, or as a way to look at how you think UI states in terms of state change, okay. You get a state that you want to generate view out of this, okay, and then you have now how to structure your state well, because this was caused the most bugs here. So React come with this particular principles that also take borrow from the database engineer known as normalization, where they say, okay, now this normalization is just a way to eliminate redundancy and duplicate data. So in the case of React, we have now is, well, avoid any or group state related each other, avoid any contradictory state, avoid redundant state, can I get this information from its props or from another state, avoiding duplicate state, because it makes very hard to sync, okay, as well as avoid deeply nested object in your state. And by deeply nested object, this is an incorrect way to talk about, because after all, this deeply nested object is just an object that points to a property from that. So in any case, once we look at that, okay, now when it comes to actually share that state across different components, this is when this is a common thing that you're gonna do, known as state lifting state up, which is the way of how you know, or the way each unique piece of state, you will choose which components owns it. And by doing that, your goal now is to say, this is the source of truth of all of these components that make use of that. So that's one of the reasons why, for example, we have things like Redux as a way to now split that or make it much more easy to manage, okay, in our yeah, so way to make it much more easy to manage that. And so with that, we will now be able to describe and understand the importance of now having this single source of truth, and how, for example, in the case of when you're writing your components, in terms of sharing its state between them, those components that whose informations are driven by its state is known as uncontrolled component. And those components that are driven by, or that use that information from its prop primarily, it is known as a control component. Again, all of this becomes quite fuzzy when you're going to describe that, but the idea here is that those components that use a state usually are for configurations, and they are less flexible, whereas now those components that actually receive their data from its props, now they are much more flexible. You can also have a combination of that. We also look at how can we now defining those components, okay, and especially, which is something great as you're starting to think here in React, where first you're defining the data, and then you have the mockup, okay, interesting. Yeah, first you have is the what you want to show. You have the mockups, and then your data, okay. So then you're starting with creating is the hierarchy of your components, okay, building a static version of that, and then you're gonna find is the minimal but complete representation of the UI. So for example, when you're writing this kind of component, okay, you ask yourself, hey, does this data remains unchanged over time? If it's that's not an state. Hey, does this data is this data is passed by this prop? It's not an state. Is this data can be computed based on it is in another state or a props? This is definitely not a computer. So anything that remains is probably a state. So why I'm describing is this? Because when you are now sharing your state, okay, and the way to do that is by, well, what are the common components that you want to make use of them? If they have their own state, the thing is that you want to lift them up, which means that remove those state from those child components, putting in the parent. Now our core is the components, the child components and the parent level as a way to now pass that data there. Okay, so you can actually see that actually they're receiving is the proper data. And then you now is connect the handlers from the child component to the parents. That's quite interesting. That's very, 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 very interesting. Totally, totally. So, on that topic, okay. Now that we know how can we do and what can we do, and several ways of how to do that kind of thing. All right. Um, it is interesting because now that we look at how to do that, why we do that, and all of this terminology that are useful to describe as a way to go on build now scalable application, it also is important to understand now, as we remember, that the React is anytime we're triggering is a state updates, it creates a virtual DOM in the commit phase, in the render phase, and then on the commit phase actually reconcile with the DOM to apply only the necessary DOM updates. So states are tied to the position of the render tree. So anytime you define a state in a component, that'll be tied to the position of the render tree. Why this is important? Because if you want to reset your components, you have several components at the same position, and React by default is going to preserve the state if they are the same component at the same position. If you are, and this is useful, for example, if you want to toggle between components, the same components, okay? However, if you are rendering different components at the same position, React will reset the state of all of the sub-tree components there. Okay? That's quite interesting. That's quite interesting. So, for example, here, as they mentioned here, so React is now going to, as I mentioned here, React preserve the component state for as long as it is being rendered and it is positioned in the UI3. And the other is when you're rendering is different components. When you're rendering is now different components like this. So when you render a different component in the same position, it resets the state of its entire subtree. And then you get now is resetting a state at the same position. So what if you want, for example, now reset the state at this of the same component at the same position, okay? Well, if you want to reset the state at the same position, because by default React now preserves the state of the component of the same position, so you can either render the component at a different DOM position or render position, or you can use a key as a way to indicate to React, hey, this is a different component. So this is something interesting, because this way is how you can, for example, is resetting the state. If you have now, if you have for example, if you want to reset the state with some basic data, and this is something very, very, very useful and powerful for that. Okay, if you want to reset the state, for example, here, reset detail form. If you want to reset is the particular page, okay, by passing is the proper data, like that, you are now is to add a key to this. But in there, instead of a contact list, you add is a key. You add is a key that actually indicate to React, hey, I want you to now is to keep track. I want you to make you to keep track is with the selected ID for that, right? So now, because we're keep tracking is the selected ID, and we are assuming that all of these selected ID are unique, okay, because it's make selected ID, exactly. On selected ID, we are making sure that all of these ID are unique, assuming that the data is unique. So now we can actually is reset the state with this proper information that they have, but based on the data that we're passing to them at that moment. So when you select the ID like this, you're not only triggering is that the selected ID, you're not only updating the selected ID, which means is that now it's going to re-render this, but also select the contact where we're going to have now is the ID selected. Give me this only one element, okay. And I want you to pass down to this component. So this is now something interesting that you can do, especially if you have, for example, a dashboard. When you want this to actually pass is, let's say you have a dashboard with yeah, let's say you have a dashboard here. Totally. Totally. Yeah, let's say you have a dashboard here with let's say you have a dashboard now. What you're gonna show is the analytics, the contacts, and that kind of thing. And with that, now, anytime you click here, when you select that data from that particular state, you can actually take a look at the Redux, which is the central store, as a way to now, once you get this data, once you get all of this collection of data here from this user, as a way to show all of this piece of data, you say, okay, this is now the selected user. What will be is the selected data that I'm going to get here, and I'm going to pass that data to the other component. For example, here you have now your columns of all of this data that you want to know, this dashboard that you want to pass. All of this data that you want to pass, right? So because you want now to pass all of this data to them, okay? The idea here is that when you click on them, you're going to reset the state with this proper data that you are passing through. If you click here, you're going to now reset the state with this proper data that you're passing through. And that's quite interesting because this enable is to reset the state, okay? Or if you want to preserve that, well, you just only is show this component as it is, okay? Or show the same component as it is. For example, if you don't pass any data here, it's actually showing is the same data. It's preserving that. But because you are telling now to React, hey, I want you to now keep track of these elements, which means therefore I want you to now hold and state of each one of these components. And when I call them, I'm going to pass is the proper data for that. This is something interesting, a way to look at how you can work with dashboards and chat applications and that kind of thing. So, because of that, then I look at how can we now make our state update logic maintainable, especially when a particular state needs to react to several inputs. Say typing, a most common example of this is like forms. Okay, so the more input you need, the more input this state needs to react, the more sense it will make to create is a reducer. And how by creating this reducer, and how by creating is this reducer, And how by creating this reducer, okay? So and how by creating this reducer, and how by using is this reducer, which is just a function that takes an state and a new, that takes an state and an action object that indicate what will be the input or what will be the chain that you want to perform. Okay, and this object is made of the type, where it's actually when you define is what is the state or the UI state that you want to represent here, and then it's going to return is a new state to indicate, to react, hey, this is the new state. And that's quite interesting, because this will give us not only much more control about which data can we update, okay? Totally. This not only tells us which data should update, okay? All right. Exactly. Which data should be updated? Okay. And yeah, it's not only tell us that, it's not only which data should be updated, okay, but also having much more fine-grained control about how we are going to update our state. And that's quite interesting. Very, very interesting. Again, the more input that a state has to manage or react, the more it makes sense to use a reducer. So then we look at how can we now pass data to distinct components using context, because it solved this particular problem known as props drilling. And the point of this is, so instead of passing all of this before using a context, evaluate passing your data as props. Okay, or extract that component into a JSX and then pass that data to that. If that actually is not helping, or if that is not a helpful topic, tips, then it is much better to actually say, all right, now it is time for us to, well, now it is time for us to use a context. And after all, a context is just represent that which context other components can read and provide. The way how you can create that is using a create context. We create a context in a file, and then we use a context from the component that is need to using the use context, or you can provide the context from at least a element or for at least a higher element that where the component is going to be used. And you're using is the provider tag. So you might think when this is useful. So for example, when you want your components to be aware of its surrounding, for example, themes or user authentication, now it makes much more sense of that. Totally, man. Totally. And the other is that, for example, React libraries like React Router actually make heavy use of this as a way to now keep track of which URL when you're navigating you are currently at. And the other is that use context when it makes much sense to actually manage multiple state, or when it comes to react to multiple inputs in a state, combine that with reducer. So this is now when things started to make powerful. This is scale that, because now this indicates something interesting, and that is you can have is a context which it allows you to pass down data to different components, and a reducer to keep your state update logic maintainable. So when you combine them as a way to scale now your state management, you can do that. And right now, context is actually quite powerful because initially when it was released in React 16, it was a mess. So it's like it was a no-no. But here now, with the context and reducers, we are now able to, in one file, define is the context for our state, the context for our dispatch, okay? Inside of the function, we're going to define is down the line, down on that folder is the reducer functions, okay, as well as the initial state. And then the function, the function that we're going to return is the providers based on the value that were passed from the state, on the context from that, context.provide and the value from the state using the reducer, and the context.provide from the dispatch from the user or from the dispatch there, followed by its children. So now this is a way of how you can make this particular data available for any other components that make use. There's a caveat, because with React will re-render components that read, or that, so React will re-render all children components that use, because that's one of the caveat, one of the gotcha here of use context. Because React automatically re-renders all the children's that consume or that use a particular context, starting from the provider where starting from the provider that receive the value, that receive a different value. So that will cause is perhaps anytime that value change, it will cause now re-renderings for that. Another technique that you can use, for example, is in your providers use is MIMO or callback as a way to now avoid or to catch, in the case of callbacks, the function between re-renders as long as you pass some array of dependency as a way to when you want to update this. And the other is the same for MIMO, to catch some computation between renders. Okay, so that's actually quite interesting. That's very, 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 very interesting as a way to recap about that. Yep, and I did that in 1 hour. And I think that's quite powerful. And then we're gonna take a look now in the next section about is this escape hatches. So let me take a break here, and we're back. And we're back. And we are back. Okay. All right. Oh, let me wash my hands. finally, we are back. There you go. All right. There you go. All right. So, in today's or uh, in this hour, I'm going to now dive deep into this particularly two topics, but specifically to the synchronizing with effect. So far we have looked now how can we now describing the UI, adding interactivity, and then managing our state as a way to now make it much more easy for us to create our UI state, create our UIs as state change, okay? And how can we is to create our state in an organized way, as well as how can we now share state across different components, how can we resetting and preserve the state, as well as how can we make our state update logic consist, pass data down to different components using context, and how when you want to combine context with the reducer, how to make your application much more easy to manage your state updates, as well as to share your state. So it also comes with trade-off, of course, like anything. But once we know this, and sometimes our React components needs to actually interact with, we need to control or sync with external systems. So for example, when you are now in the browser, you want to focus the input to a button through the browser API, or you can play or pause a video that is implemented outside of React, or perhaps you want to connect and listen to message from a remote server. This is the thing when we are going to look at how can we now is step outside of React, okay? As a way to allow us these specific things. Remember that at the end of the day, all of the things that are describing in the learn section is just as a way to see how now Facebook are facing their problems. Not everybody has their Facebook problem, and if you do, please send me a check. I will gladly to work with you. But it's to also recognize that this is specific use cases. So how to remember information. So we're gonna look at briefly as that how to remember information without re-rendering, as well as how can we now manipulate the DOM, or how to access DOM element managed by React, like this, or exactly. So how to access DOM elements managed by React, or aka manipulating is DOM with Ref. And then what is relevant for us is to how to synchronize components, how to remove unnecessary effects from your components, and how an event and how an effect life cycle is different from a component. So because now, and again, the idea of actually recapping these things is escape hatches, or things that allow you to step outside of React as a way to or control or sync with external systems, whether it's browser APIs or whether it's communicate with remote servers. For this specific case, first we'll look at how can we now remember things without trigger rendering using the useref, where now this is something that is like a special pocket in React where we can store information under the .current. Okay, so if we want to read information or mutate, meaning read and write, you can do this. So it is important to not using that during re-rendering. If you need that, well, use state for that. And one of the use case for this is to identify timeouts. When you're performing this async operations or using the callback, using the timers for timeout ID, or to get elements or get DOM elements, which is something that we're gonna see, get DOM elements and be able to work with them, or any other objects whose don't need it to evaluate at rendering time. So because the most case we're gonna see that, and also I look at how can we now create our own stopwatch, which to me was quite interesting, very interesting to see that, because anytime you say like, okay, I want you to build is a stopwatch, okay, I want you to build is a stopwatch, and not everybody is willing or knowledge of how they can create that, right? And how you can create a stopwatch. And I think this is something that is fairly common that you're gonna build that a lot of the time. So this state, it's this stopwatch. After all, this is a JavaScript function, a JSX function. What it's going to return is, well, the div here. What you're going to show is now is the counter or the stopwatch. Okay, we're gonna use here now is this one, h1. Okay, and right below we're going to here we're gonna show the data stopwatch. We'll say hey h3 here. We're gonna show the data here. And we're gonna wrap this, of course, into a root element, because this is something that all JSX needs to, part of the structure they follow. Okay. And right below we got this a button here, where this button will say, hey, this is the start. So this is something pretty simple, because now we're gonna say is what are the things that we need to. So now that we define is the different visual state, which is initially 0 0, as well as running. So this is the two state that we want is to actually create here, these two visual states, and also determine what trigger those state updates, which is on click. Now it is time to define is the minimal state that allows to represent that state, which is, if you take a look at this, is find the minimal but complete representation of the UI state. So, because we look at how can we represent this our UI, yep, we look at how to think UI change as a state change, which is okay. We need to find out. We need to actually define is the minimal state here, which is the now, and the now, okay, which will actually is the one who's gonna count, and start time, okay. So here we say start time, and set start time, okay, which is good. Here we're gonna say is use a state which the initial state will be 0. All right, the same state, because this state we're gonna change over time. So this is the reason why we choose this as a state, because they are candidate for that. Start time, set start time, and then now, right? And so we have to count that, and set now. So with this, use a state like 0, right? So with this, so anytime we click here, so now that we define is the minimal representation of a state, the minimal state, the minimal UI representation, or the minimal but complete representation of our UI, the minimal but complete representation of our UI, okay, which is start time, and now when it counts that, okay, the minimal, the minimal but complete representation of the UI state. That makes sense. The minimal but complete representation of the UI state. So initially we had 0, okay, and then we also have is when counting. So we're going to now is determine what triggered those state update. In our case is on click, okay, and we're gonna handle this, say handle star. We're gonna define is our function that's gonna handle that handle star, okay, and here is when we're going to define is our timers. So we can say is anytime we set our timers here, we want to start from the beginning. You say start time, or you say this one, start time date dot now, which is a time step, okay, in milliseconds. Similar for this, set time now, it's a time step in milliseconds as well. And the other, right, is this is start time, set start time, now, set now. And now is when we're going to actually is perform this sync operation, or let this now using the timer set timeout to do this. All right, so because here we're going to pass is a callback function that I want you to evaluate this every 10 milliseconds, followed by the set now as the current date, okay, so set this date without this with this time step, with this milliseconds, and then after 10 milliseconds with this milliseconds, and so on and so on and so forth, okay, because here we're creating is a reference of the callback that we're gonna send. So anytime we handle this, or anytime we click on this function over and over and over, we're telling to the browser, hey, create now this timer. It's meaning that, hey, please add in a new reference, a new place in memory, hey, this timeout, this function, emit this function anytime when that pass. So the more you click here, the more it's going to populate that in memory, which is something that you don't want. That what you want is to, when you start, is release that space in memory and then create a new one. And the way to do that is by actually using is a ref here as a way to hold me a reference of that timeout. You say timer ref, okay, or timer ID or timeout ID. Okay, give me a reference of this, because ref, after all, is a secret pocket that remember things without trigger re-rendering, which is great. Use ref here. Okay, and what we're gonna do is to, anytime you get in this, you trigger this state to actually show the counter. Okay, before that I want you to hold the reference, and if there is nothing, I want you to, if there is nothing, clear interval, if there is nothing, or if you have something, I want you to release that memory for that. So clear interval, what it does is that from our timers, clear interval does that. It says, hey, I need you to pass me is this interval ID. Okay? So I want you to stop this and therefore release that in memory. So that's right. Otherwise, then let me now actually is assigned to the timeout ID ref.current, which is, this is now the property that this useRef contains. Okay, and that'll be all. You know, it's going to evaluate this, and now it's going to actually every 10 milliseconds is set this, set the now to this, meaning it's going to trigger a rendering. You're going to pass through the trigger. Okay, when this React will say, hey, when this state change, oh, it was at the component level here in the stopwatch. Okay, now let me compute all of the props and states and event handlers here. This entire function, let me compute that. So I want you now to compute is this. It's going to define is a new variable called, let's say, start counting. Okay, where you're rendering this function or calculating this function, I want you to first set that to 0, and then it's going to check if the next or if the start time if the start time is, in this case, let me put it here, null or null. Okay, so if the start time is different to null, and you may wonder why null, okay, which means is that we already clicked in this component. Okay, we are triggering is that if the start time is null and the now is different to null as well, and null is absence of value. It was defined, but it doesn't have any value there. And an example of this is it's pretty much like you have an empty cabin. Okay, it was, the cabin exists, but it doesn't contain anything. Pretty much like this. And if that is the case, okay, now I want you to is, well, starting to, so give me is this per second. In other words, start counting. Let's go to compute is this. Let me take the start time. Let me take the now minus the start time as a way to have the difference. Now minus start time as a way to have the difference. And I want you to now, because it's giving in milliseconds, I want you to now give me is in seconds. And that is something that I want you to, anytime you are rendering is this, I want you to evaluate that. But because I want you to show at least some other seconds or some other, or to represent is milliseconds and that kind of thing, I want you to now to fix, which is something gray here, to actually show is these milliseconds here. So now we were able is to create this piece of content. Let me actually remove this. Yeah, like stop or time pass. It's time pass. Exactly. So time pass from that, and then when I start here, okay. That's right. Set timeout here. It actually is printing this. No, there is nothing wrong with that. But it's like handle start counting. It's like it's not evaluating this, which is now minus start time divided by 1000 is quite interesting. Here we are clearing the interval at the beginning, okay, which is null. And for some reason it's like we are not triggering is this. Okay, I want you to set now this, followed by the date now. Exactly. And you should be called this every 10 milliseconds. Set timeout, and that's it. So if the start time is different to null, and now is different to null, which means that you start, then you're gonna do this. Oh, exactly. Then you're going to evaluate this. Now minus start time, it'll be like this. If the start time is different from null, exactly, start time here, and now, then I want you to now evaluate this and then divide this result and take and assign that. So timeout ID ref, oh, because it's like this. Oh, okay, I get it. It's because the way how we're passing is the reference here, because it actually will hold the references on the current, and we want to assign the values on this. We can do something like this. It actually works. It's supposed to work as expected. No, we don't. Okay, no problem. Oh, because we assigned that as accounts, that's what happened. Okay. Again, this is supposed to work like this. Okay. Or like this. That's quite interesting. let timeout interval here, and timeout ID, use ref for that. We are getting that. Okay, let's set timeout. And when we are starting here, we say, hey, is this null? No. That's right. So now calculate it. So if both of them exist, so now what you're going to do is to actually, well, show that. Show that. Let me see here. Set timeout start time. Okay, and set now here. This is now what we're going to show initially. Okay. The timeout dot ref. And start counting here, and I want you to do is this, right? Exactly. When we click here, is just computing is this once. But we are going to create now is this. When we hold this reference here, timeout ID ref, and oh, okay. Ooh, give me a second. And we're back. That was fast. I love it. So why this doesn't work? Okay. We're pushing as this. We're cleaning the turbo if there is nothing. Otherwise, we're gonna send this. It only render this once. It only render this once. But we want it to render it several times. Set timeout. Did I mention it right? Set timeout. No, it's working. But on click handle star, which is the start button, set start time. That's right. Set now. Okay. And you should now be able to run this function every 10 milliseconds. Oh, because it's only the current. Wow, why this is not working? For Intel Word Ref. When we let me see this. So when we click here, okay, we got an issue here. Set timeout. Of course, it's, oh my God, never. It's because it's set interval, not set interval. Exactly. So now it actually worked as expected. You know, so far so good. So we were able to create is this time pass, right? So and then we will always able to see how now can manipulate, which is one of the particular use case when it comes to actually use ref or this secret pocket. Okay, first is with timeout IDs. The other is with DOM manipulations. So we look at how can we do is by focusing elements here as a way to put now a ref where you tell React, hey, I want you to now put the input HTML element into the current, okay, property here, so we can now actually handle that. The other is scrolling to an element. So for example, these two specific things, when it comes to manipulating DOM with ref as a way or to focus inputs or to scroll to an element when you need, or perhaps you want to measure its size and position, this is now way of how you can do this. We also look at how can we actually indeed do that. Okay, So focus the search field and the scroll and the image carousel and that kind of thing. Very narrow specific things here. And when it comes to actually what we care about this, which is synchronizing with effect, is like this. Some components need to synchronize with external systems. For example, you might want to control a non-React components based on the React state. Okay? So some components need to synchronize with external systems. So we look at how can we now control and synchronize with external system, and now we synchronize. How can we control and manipulate is the done using the ref, this memory between renderings, between re-renderings without trigger rendering, okay? And when it comes to synchronize with effects, some components need to synchronize with external system. So for example, you might want to control a non-React components based on the React state. Okay, so given this particular state that I define in React, I want to control a non-component or something that is outside of this. Set up a server connection or send an analytic log when a component appear on the screen. And I think this is the most fairly common that you're gonna find here. Hey, how can I add this? How can I add an analytic logs here when a component appears on the screen? Okay. For example, you might want to control a non-React component based on the React state. Set up a server connection or send an analytic log when a component appears on the screen. So effect let you run some code after rendering. My question is, after which phase of the rendering? You know, it is immediately right after the rendering? Okay, so okay. Effect let you run some code after rendering. In other words, that after now, React recall all of your React components, create the virtual DOM. Now, React or Effect let you to run some code after rendering, before the commit phase, so that you can synchronize with your component with some system outside of React. But I think this is something interesting as a way to see how this piece fit together in the entire rendering triggering. Okay, it's like rendering mechanism, how effect fits in the rendering mechanism. That's the question here. Okay. So effect let you run some code after rendering so that you can synchronize your component with some system outside of React. That's right. Effects let you, according to this, effect let you run some code after rendering. The question is that this bit is okay. So before the commit phase, and that might be that makes sense here, and that makes sense here. That makes a lot of sense. So rendering, so you can synchronize, your component, so that you can synchronize your component with some system outside of React. After we evaluate that, after rendering, okay, now you can synchronize with some external system. Now you can synchronize with some external system or some external call here. Okay, So now that you got is this rendering mechanism, okay, you will learn what effects are. Is this particular code that allow you to is this or effects let you run code after rendering, so you can synchronize with your component with some system outside of React. And you will learn is what effects are, how effects are different from event. Okay, of course, because after all, events are being evaluated during rendering, and effects is a piece of code that is running after the, oh my god, and that makes sense why we use, for example, what we look at, for example, is layout. For example, is use layout. It's like use layout effect, because and that's one of the reasons why you must understand how the thing works. Again, this is a very narrow specific use case for that, because use layout effect is a version of the use effect that trigger before the navigator paint the browser. You know, before the next tick actually here is, so it means that use effect is being is mean that use effect if your effect wasn't caused by an iteration, exactly, if your effect wasn't caused by interaction like click, React will generally let the browser paint the update screen first before running your effect. If your effect is doing something visual, for example, positioning a tooltip, and delay is noticeable, for example, if flicker, replace use effect with use layout. But this is what happened here with the effect. So because effect allow you to run is a piece of code after rendering, it means that after the browser paint the update screen, okay, so yeah, exactly. React will generally let the browser paint the update screen first. It means that it already passed through the reconciliation phase. Okay, the update screen first before running your effect. So before running your effect, React will let the browser paint the updated screen. It means that I already passed through the conciliation process to the commit phase. If your effect is caused by an interaction like click, React may run your effect before the browser paints the updated screen. And there's several caveats here, several scenarios here. If this was caused by an interaction, if your effect is caused by an interaction, your React may run your effect before the browser paints the update screen. If this was not caused by an interaction, like a click, so then you get this. Usually this works as expected. However, if you must defer the work until after paint, such as an alert, you can use set timeout for this. Use effect fires synchronously when it is the result of discrete inputs. Four participants here. React Core Team, Next.js and Vercel. If your effect is caused by an interaction like click, React may run your effect before the browser paints. Even if your effect was caused by an interaction like click, React may allow the browser to repaint the screen before processing the state updates inside of your effect. Usually this works as expected. However, if you must block the browser from repainting, you need to replace the use effect with use layout. Hey, I want you to block that. But this is because it fires before the browser repaints the screen. Okay, to prevent this flashy things. Especially if you want to render elements like that. For example, updating elements in a text box. A very narrow specific case, man. A very narrow specific case here. Uses: connecting to an external system, wrapping effects in a custom hooks, controlling a non-React widget, using a useRef for that. Exactly, controlling a controlling a non-React widget or component there. As a way to synchronize with external system, that is code that is executed right after it renders. After the rendering, fetching data with effect, specifying reactive dependencies, updating a state based on previous state from an effect, updating a state based on previous state. Since count is a reactive value, it must be specified in the list of dependencies. This is a way of how you can now trigger a code that is going to run after rendering, as a way to say, hey, you can now have a counter here. So when this element, when this element is run, oh my god. It's because this is a code that is run after rendering. This is a code run after rendering. The object is created from scratch on every rendering. It is used inside of the effect, and as a result, these dependencies are always different on re-rendering. So you define then here. And this will be only called when a different room ID is selected. But again, it's a code. Okay, It's a set of instruction that is running here. On every render, removing unnecessary function dependencies. It is used inside the effect. As a result, these dependencies are always different on a re-render, because anytime is this component render based on when you set the state, it will create this new objects. It will create this new function reference there. So a way to prevent that, you can is catch that or run that inside of that effect. Hey, this is the code that I want you to run after rendering. Keep it. And when the ROM ID change, okay, and when the room ID change, well, I don't know where you get, okay, when the room ID change as a props, all right, that's right. Under construction, this section describes an experimental API that has not been released yet. This section describes an experimental API that has not been released yet. Removing unnecessary dependencies, reading the latest props and state from an effect, displaying different content on the server and the client, returning a client only JSX, returning initial JSX. But that makes a lot of sense here. Okay, that makes a lot of sense of what is an effect, which is a code that runs after rendering. So you can synchronize your component with some system effect. Okay. How effect fits into rendering mechanism, bro? Exactly. How this fits into rendering mechanism. Okay. How effects are different from events. Good. But now that we know what effects are and what effects are allowing to do, which is synchronize with external system, okay? So for example, you want synchronize. For example, you want us to control a non-reacting components, map-leaf, for example. You want to control a non-reacting components, all the JavaScript components, or you want to set up a server connection and send you want to set up a server connection here, or send an analytic log when a components appear on the screen. Hey, when this component appears on the screen, I want you to send some metrics here to the analytic aspect. So in this case, are they actually looking at that analytics? Exactly. They have now is a context analytics service. Set the analytics here with this code when it's going to actually connect to that LogRocket identity and Pendo identity. Mm-hmm. In this analytics, here, mobile header menu, auth context, and the authentication as well. For analytics, exactly, default auth state, for analytics. For analytics, when you have is the auth state and the actions. And the analytics. Analytics set identity for that. Auth action type, set identity, set token, logout, set token, and set user. That's quite interesting. That's very, 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 very interesting. So now you have analytics here, set identity and clear identity, LogRocket clear, but they define this as analytic. So the context is handling is here is analytics, my friend. The context here is handling is analytics, bro. Auth provider, we're gonna return this, but the other is the, in this auth provider you have the auth reducer and get default auth state, which is this. You're reading from the local state. And then you define some use effect as a way to synchronize with systems outside of, as a way to run this code after rendering to help us synchronize and control other systems, external systems. So for example, local storage. And when the auth state.token change, I want you to now run this code. Again, your application shouldn't heavily rely on this feature, useRef or useEffect. If they are, it is time to rethink of them. Again, this is something that they describe here. Yeah, most of your application logic and data flows should not rely on this feature. They must rely on managing the state, your application logic, and the way of how you're going to render all of these UI elements, and the data flow. They should not rely on this feature. Most of your application. That makes a lot of sense. That makes a lot of sense. Mhm. And only when this state change, all right, I want you to do is this. Holy moly. Oh, okay. Let's going to keep looking at this. Let's going to keep reading of this. So what are effects and how they are different from events? Before getting to effect, you need to be familiar with two types of logic inside of your components. Rendering code, which is describing the UI, okay? Live at top level. Okay, this is the two type of logic inside of your React components. Rendering code, which is describing the UI, and that is, well, your React components, aka function components, how you can import and export them, use JSX for that, how you can conditionally render components, list of components, and how it's important to make them pure. Okay, so rendering code must be pure, like a math formula. It should only calculate the result, but do not anything else. And I really like that analogy here, because your rendering code, which is after all your React components, must be pure, like a math formula. It should only calculate the result, but do not anything else. Event handlers introduce in adding interactivity here. Okay, and event handlers. So this is the two type of logic inside of your React components. The rendering, and this is something useful, especially when you're going to describe this, as a way to identify that, and when you need to actually detect some performance issue, you say, okay, what is the rendering code? What is the event handlers? Okay, what is the two type of logic in your React components? Rendering code and event handlers. Introducing adding interactivity are nested functions. This is where you take props and state, transforming and returning the JSX you want to see on the screen. But it's rendering code, okay, this is where you take the props, states, transform them. This is when you take the state, the props, transform them, and return a JSX you want to see on the screen. And rendering code must be pure. Event handlers introducing adding interactivity are nested functions inside your components that do things rather than just calculate them. Exactly, are nested functions inside your components that do things rather than just calculate them. An event handler might update an input field. Exactly. Submit. Exactly. An event handler might update an input field, submit an HTTP post request to buy a product, or navigate the user to another screen. Event handlers contains side effects. They change the program states caused by a specific user action, for example, a button click or typing. Sometimes this is enough. Consider a chat room component that must connect to a chat server whenever it is visible on the screen. Connecting to a server is not a pure calculation, it is a side effect. So it can happen during rendering. Because this is okay. So connecting to a server or talking to things that are outside of this system performs a side effects, so it can happen during rendering, because you need to render that and then let this thing happen. Okay, for the UI perspective, it is visible that connecting to a server is not a pure calculation. Exactly, because it's not synchronous. Connecting to a server, connecting to any external system is not pure calculation, aka is not synchronous. You have to wait for that. There's some side effects for that, meaning that the server can return true 200 or 404 or 500, some errors there. So it can happen during rendering. However, there is no single particular event like a click that caused chat room to be displayed. Effect let you specify side effects, which is this non-pure calculation, or this things that happen outside of the React that are caused by rendering itself rather than a particular event. Let's get into this. Effect let you specify side effects. Okay, so effects let you specify side effects that are caused by rendering itself rather than by a particular event. Oh, okay. When it's something, okay, when something is the rendering by itself, effects let you specify that. Hey, instead of actually rendering is this UI based on an input, especially human input, I go now is to rendering this by itself. Sending a message in the chat is an event because it's directly caused, because it's directly caused by the user click a specific button. However, setting up a server connection is an effect. Setting a server connection or this computation is an effect, is a side effect, because it should happen no matter which interaction caused the component to appear. So, because regardless so effects let you specify side effect, and by side effect is code that happen outside of this function that are caused by rendering itself. So anytime this component render itself, I want you to now run this code. For example, is connecting to a server and listen to message, or for example connecting to a map. However, setting up server connection is an effect because it should happen no matter which interaction caused the component to appear. Effect run at the end of that okay, this is exactly what I want to know. And I get it. Effect run at the end of the commit of a commit phase. Effect run at the end of a commit after the screen updates. This is a good time to synchronize the React component with some external system like network or third party. This is interesting because now these effects run at the end of the commit after the screen update. It means that after the reconciliation process, okay, now this code is run. After the reconciliation process, aka after now the screen's updates, the effect runs. So you now run this code for me. If you do this, running this code after the screen updates, you will now hold some data there or some code there. You're running some code as a way to synchronize this. This is a good time to synchronize the React component with some external system. After you paint that, or after you trigger render and commit that, now you also have is another phase, I will call this, that is the effect. And in the effect, which happens after the browser or after the screen updates, or after the browser updates the UI or paints that, this is code that is running here. Here and later in this text, capitalized effect refers to the React's specific definition above. It adds side effects caused by rendering. Side effect caused by rendering. To refer the broader programming concept, we will say side effect. You might not need an effect. Don't rush to add effects to your components. Keep in mind that effects are typically used to step out of your React code and synchronize with external systems. When I want you to get out of the React code and synchronize with React with some external system, effects are the way to go. These include browser APIs, third-party widgets, network, and so on. If your effects only adjust some state based on other state, you might not need an effect. So if this side effect or is this computation is adjusting some state based on another state, so you don't need an effect. But again, the whole point of the effect is that let you specify side effects or code that'll be run after the render, after the commit phase, which according to the React this is the perfect time to update or to synchronize the React component with some external state, okay, with some external systems like that. So effect like you specify the side effects that are caused by rendering itself, and rather than by a particular event. So effect like you specify side effects that are caused by rendering itself. Is this component is rendering itself, side effects are run rather than a particular event. When you are setting the state, you trigger a render, okay? So the way you trigger the render is inside of your event handlers. So this event handler is what is triggering a state. Usually this is based on user inputs, human inputs. So sometimes you want to do now is render or run some code as a way to synchronize or control external systems. So if you want to, for example, is, well, the browser API, the chat, okay, let's say you're creating a chat. So this piece of code that happened at the end of the commit phase allows you to synchronize the React components. And they say that this is the best place to synchronize those React components. Okay. You might not need an effect. But again, they say that effect like you specify side effects or this computation that are not pure side effects, okay? So computation that happen outside of the rendering phase. However, there is no single particular event like click that caused chat room to be displayed. So effect like you specify side effects that are caused by rendering itself rather than a particular event. So you can use now this piece of code as a way to run, or you can use an effect as a way to run this piece of code when this is caused by itself, by rendering itself, rather than a specific event. You might not need an effect, so don't rush to add effects to your components. And keep in mind that effects are typically used to step out of your React code and synchronize with external systems. This includes browser API, third-party widgets, network, and so on. If your effects only adjust some state based on another state, you might not need an effect. How to write an effect? To write an effect, follow the 3 steps. Follow these 3 steps. Declare an effect. By default, your effect will run after every commit. After every commit phase, after the reconciliation happens, specify the effect dependency. Most effects should only most effects should only rerun when needed rather than after every render. For example, a fading animation should not only trigger when a component appears. Most effects should only rerun when needed. Specify the effect dependency. Okay, this is now the anatomy of the effect, or how you can write your effects. First, declare an effect. By default, your effect will be run after every commit. Specify the effect dependency, and most effects should only rerun when needed, rather than after every rendering. But again, effect lets you specify side effects or code that are caused by rendering itself, rather than a particular event. So at the beginning, this might sound like a jargon, mumbo jumbo, but this is telling you, hey, this piece of code, it will run. So this piece of code, it will run by rendering itself. Okay, you remove a lot of the jargon. Is this piece of code will run itself by rendering this component, okay, rather than a particular event. It's because there is a lot of here going on. Okay, so effects lets you run this side effects or this code by rendering itself. Okay, that's it. Which means that by calling itself, by calling this component. Okay, instead of a particular event. And the way this code, and when this code will be run, it'll be after every commit, after the reconciliation with the DOM. So you can, when we talk about now states and the rendering phase, each state is a snapshot of it. So states are state is a each state or states are snapshots, or it is a so state is a snapshot for every re-rendering. That's what is a state, and they are not synchronous, so you don't get the value in that moment. You will get the value in the next render. Okay, so states are snapshot for every re-rendering. So every re-rendering, you can think of the state as a snapshot for every re-rendering. And in the effect, which now runs at the commit phase, right after that, okay, it makes a lot of sense. So now here, after the commit phase, this run will be so effect allows you to run code right after the commit phase. So effects allow you to run side effects or code that happen outside of the React component as a cause by re-rendering this component. So even when this component is called or rendering, effect will run that. Effect will allow you to run this code right after the commit phase, aka when the screen updates. So now we have is all of this different rendering mechanism in place. Okay? Holy moly, bro. Holy moly. So far so good. Things are starting to slowly make sense. Okay. Specify the effect dependencies. Connecting and disconnecting to a chat room. Okay. So here we're looking is that when you don't need an effect, okay? And I get it when they mention that is because this particular code that you want to run after the commit phase, after the screen updates, this is the best place for you to synchronize with external system, according to that. Because now this code will run when the component is rendering. So now that we understand is this particular mechanism, how they're going to build up, you have now the trigger, you have the rendering, when it evaluates is everything in that file, in this case all the props and states, event handlers, and also if you have an effect, it's say, let me actually hold that information, okay, continue to call React component if you already if the JSX contains more in a recursive way until there is no more React components. Then on the commit phase, let me now apply then on the commit phase, once I create this new virtual DOM, virtual representation of the ideal UI that we can keep sync with the DOM. So in the commit phase, now I have this virtual DOM, this new version of the virtual DOM, and I'm going to reconcile with the old virtual version of the DOM. And this reconciliation phase is now the React Fiber, which is this reconciliation engine, which is now adding some data to the render tree. And when that reconciliation happened using the diffing algorithm, this series of steps, okay, now it is time to actually apply all the necessary or to sync with the DOM by applying only the bare minimum necessary updates to that, and then all right, now you can so the browser detects those changes, render that screen or paint that screen, okay, and therefore now React, because you define the effects, it say, okay, now it is time for me to run this code right after the screen updates, after every commit. So now that we have this mental model here, specify the effect dependencies. Most effects should only rerun when needed rather than after every rendering. For example, a fade animation should only trigger when a component appears. Connecting and disconnecting a chat should only happen when the components appear and disappears. Or when the and I get it why you now when you return a effect this is the cleanup phase. You say to this component, hey, I don't want you to now run this piece of code when you render. When React render this component. Or when the chat room changes. You will learn how to control this by specifying dependencies and add cleanup if needed, which is when you return that. Some effects need to specify how to stop, undo, or clean up whatever they were doing. For example, connect needs disconnect, subscribe needs unsubscribe, and fetch needs either cancel or ignore. And you will learn how to do this by returning a cleanup function. Especially when you want to clean up this cleanup face like that. And because here they are using now is this, not on the plugins. You query client. And of course, it must be use Redux Toolkit. That's right. I wouldn't go with solution like Sunstats. Bullshit. Man, this is a business, and business needs certainty. Business can update as they see fit, but they must use existing tools that are robust, mature, and popular. So in my case, it's like, yes, I definitely wouldn't change this. Of course, bro. Now things are starting to make a lot of sense. Route details, thing, vendor profile. Plugins, actions. Okay. That's very, very interesting there. This is fairly common. This is a fairly common application. It's nothing that fancy. Not at all. It's not that fancy, this application. Once you understand this concept here. Some custom hooks, some reusable hooks here. Like this. React Query DevTool. course, it must be use that router here. From Next. Oh, they're using this router. Okay. So now things is starting to make sense a lot with effects and that kind of thing, especially using now Next. Holy moly, bro. Okay, let's. Okay, okay. But I know what is an effect, which is a piece of code that performs a side effect or a code that actually allows you to synchronize or control with external systems caused by rendering itself, caused by rendering this component itself. Okay. Okay. So, un efecto en español es un código que produce un efecto alterno. O sea, es un código que te permite controlar o sincronizar sistemas exteriores. Ejemplo, Browser API o conectarte a un servicio, sí, o conectarte a una aplicación, conectarte a un servidor. Y es este código que se va a ejecutar cuando el componente se renderice inicialmente. Y el momento en el cual este código se renderiza o este código se ejecuta en el mecanismo de renderizado es al final de la fase de commit o compromiso. O sea, cuando la pantalla se actualiza. Ahí es donde se ejecuta este código. Oh, nigga, makes a lot of sense. Okay. Declare an effect. This is how you can declare an effect. We look at how to write effect. Declare an effect. By default, your effect will run after every commit. Specify the effect dependency. Most effects should only rerun when needed rather than after every render. For example, a fade animation should only trigger when a component appears. Connecting and disconnecting to a chat room should only happen when the component appears and disappears. Or when the chat room changes, and you will learn how to control this by specifying its dependencies. And add cleanup if needed, which is some effect you need to specify how to stop. I want you to now stop this code on cleanup whatever they are doing. That makes a lot of sense. That makes a lot of sense. Specify the effect dependency. Most effects should only rerun when needed rather than after every render. For example, a fade animation should only trigger when a component appears, and then after the cleanup is needed. But this is the way of how you can write an effect as a way to run this side effect or this code caused by rendering itself. And this piece of code runs after every commit phase. Okay, so you can specify is the effect dependency, something that I know, and the cleanup if you need it. Okay, so take a look at how, let's look at each of these steps in detail. As a way to step 1, declare an effect. Pretty straightforward. Code will run after every render, okay, or in this case, run after every commit, or they call here after every render. Every time your components render, React will update the screen and then run the code inside useEffect. In other words, useEffect delays a piece of code from running until that render is reflected on the screen. So when that piece of delays a piece, it delays this piece of code from running until that render is reflected on the screen. Okay, hey, do you reflect that component on the screen? Yes, it is. I'm going to now run this piece of code. Okay. Let's see how you can, which is exactly is that effects happen after every commit phase. Let's see how you can use an effect to synchronize with an external system. Consider a video player, React component. It would be nice to control whether it is playing or paused by passing and is playing props to it, right? The custom video player component renders the built-in browser video tag to do something with is playing. However, the browser video tag does not have an is playing prop. The only way to control is to manually call the play and pause methods on the DOM element. You need to synchronize the value of is playing prop, which tells whatever the video should currently be playing, which would call with play and pause. So that's what you have to do here. You need to synchronize this property that have this video HTML element, and that is the place and pause. Okay. For that, you will first get the ref of the video DOM, exactly, manipulate that, so you can now use the play and pause for that. But since you want us to now play this, in other words, since you want us to now synchronize with this within render, you want to synchronize this by rendering itself, now useEffect will allow you to do this. Which means that after this component calls, okay, which is until after this component render and is showing the screen, now you're going to run this piece of code. But because you want us to now run that code at once, the reason this code is incorrect is that it tried to do something with the DOM during rendering. In React, rendering should be pure calculations. Of JSX and should not contain side effects like modifying the DOM. Moreover, when the video player is called for the first time, its DOM does not exist yet. Okay, because it doesn't actually here in this case call that the first time. That's why it makes sense to actually call this effect, especially when you're rendering this component, when you're calling this component and evaluate, that particular element is not there until the commit phase, when now you get that. And it's in there when you can say, all right, let me now run this code after the commit phase. This side effect is a way to synchronize with, in this case, the video for that. So its DOM does not exist yet. So there isn't a DOM node yet to play. That's why you use an effect to say this. So for example, is this. And why we use effect as a way to say, hey, I want you to now run this piece of code, okay? I want you to now run this piece of code. Wait, what the flying fuck? So I want you to now run this piece of code, okay? And we don't even have a state here. It's playing as a way to understand if this actually contains that. That's why when we define here the is playing, as and set is playing. Now that we define is this state or this memory here, you say false. Now when you want to run is this where I use effect, okay? You say I want you to now run this code here, I want you to now run this code here. That's right. I want you to now run this code here. I want you to now run this code here, which is, hey, is playing, what is the state of is playing? Identify is playing has already been declared. Okay. Okay, no, sorry. Okay. Exactly. It's here when you detect that, and when these components render, you're going to now run this code side effect. So use effect is a piece of code that you want to run right after the screen updates, after every commit phase. So it means that when you get this code here, and when for some reason we actually update this, set is playing like this, and when we pass that to is play, meaning that here we trigger is a state update, you're going to pass through the rendering mechanism. It say I'm going to evaluate all of this expression, all of this GSX, and then when it comes to get the output of this, I'm going to now call this video player, and then I'm going to now React call this function or this React component with now this particular data. It render this component, okay, and then after it render all of those components, then it's going to, after it creates it, after it went through after it render the entire tree, or after it renders the React component, it now hold the VDOM with these new states that now pass through the reconciliation phase, okay? And that reconciliation phase actually is using the diffing algorithm as a way to now update to the DOM in the most efficient way possible, show those elements, okay? So show those elements on the screen, and then is when this effect will be run. This side effect or this code will be run. When now, of course, is the proper reference here, and evaluate that. Now it is the perfect time to synchronize. That makes sense. Now it is the perfect time to synchronize with external systems. That's fucked up, bro. That's fucked up. That's interesting, by the way. So the reason this code is incorrect is that it tries to do something with the DOM. No, during rendering. In React, rendering should be a pure calculation of a JSX and should not contain side effect like modifying the DOM. Moreover, when video player is called for the first time, DOM does not exist yet. Exactly. So there isn't a DOM node yet to call play in that moment. Because React doesn't know what DOM to create until you return the JSX. The solution here is to wrap the side effect with use effect to move it out the rendering calculation. So by wrapping the DOM update in an effect, you let React, by wrapping the DOM updates in an effect, you let React to update the screen, then your effect runs. In this particular case, you say, hey, please update the screen first and then run the effect. When your video player component renders either the first time or it is re-rendered, a few things will happen. First, React will update the screen, ensuring the video tag is in the DOM with the right props. Then, when your video player components render either the first time or if it is re-rendered, a few things will happen. First, React will update the screen, ensuring the video tag is in the DOM, and by updating the screen is that pass through the trigger render, where it call all of your React components and evaluate each one of those components, and if the output, which is a JSX, contains more React components, okay, now let's go to call this React component in a recursive way until there is no more component. So then once React call these components, it now creates this new version of the VDOM, which is a representation of the ideal UI to keep sync with the DOM. This new version is going to now reconcile with the older version of the virtual DOM, which is not a technology. This is just a computer pattern, and the reconciliation is using the diffing algorithm. And then is when now sync with the DOM updates, the browser paints, and right after that is when React say, okay, it is time for me to run this side effect code, the effects, where when you evaluate that at that moment, you say, yes, that's right, you have now that information here. When you evaluate this, you have now that information and now we got also is the reference, the proper reference for that, so we can actually interact with that element as expected. In this example, the external system you synchronized to React State was the browser media API. You can use a similar approach to wrap legacy non-React code like jQuery plugins into declarative React components. Note that controlling a video player is much more complex in practice. Calling play may fail, the user might play or pause using the built-in control and so on. This example is very simplified and incomplete. Of course, if you for example adding is if you add in the controls, for example here, if you add in the control, but you're not synchronizing with that. But what you're synchronizing is the initial state, not here, because you're not keep tracking of that state of the. But in any case, you get quite the idea. By default, effect run after every render. This is why code like this will produce an infinite loop, because this is so because this is a piece of code that runs after every re-rendering. After every render, the commit phase specifically, because this is a code that runs after every render, after the commit phase, you can produce is an infinite loop from that. Effect run as a resulting of rendering, setting state trigger, rendering, and setting state immediately in an effect is like plugging a power outlet into itself. The effect runs, it set the state which caused a re-render, which caused the effects to run, and it set the state again, this caused another re-render, and so on. Effects should usually synchronize your component with external system. If there is no external system, you only want to adjust some state base and others, you might not need an effect. Specify the effect dependencies. So first is how do you declare an effect and what's happened there. The other is that specify the effect dependency. By default, effects run after every render. Often this is not what you want. Sometimes it is slow. Synchronizing with external system is not always instant, so you might want to skip doing it unless it is necessary. For example, you don't want to reconnect to the chat service on every quick stroke. Sometimes it is run. For example, you don't want to trigger a component fade in an animation on every keystroke. The animation should only place once when the component appears for the first time. To demonstrate this issue is like this. So when you say here, calling video player, because it happened at every render. So your effect, as they mentioned here, so when you're doing is this with this use effect, you're saying you're wrapping these side effects and you're moving out the rendering calculation. With the use effect, you're saying, hey, I'm moving out this rendering, I'm moving out this code out of the rendering. I'm moving out this function, I'm moving out this code out of the rendering calculation. And this will be compute is after every render. specifically after the screen update. That makes a lot of sense. So because now that will get triggered anytime you actually actually this components re-render, okay? You can skip unnecessary rerunning the effect with an array of dependency at like empty, right? And here you say React Hook use effect has a missing dependency is plain. Either include it or remove the dependency array. So when this dependency array, so when this actually change, only that I want you to now run this code. I want you to now run this code, which is something to describe here. I want you to now run this code I want you to now run this code. So what you're telling here to the rendering is like, take out of the rendering evaluation, take this code out of the rendering. Or move out this. Take this. Okay, what you're saying here is that take this code out of the rendering here. Okay, and you're gonna run that after every re-render in this case, or after a particular dependency change. But you're gonna run that code is when the screen update, after the screen update. Holy moly, man. So the problem is that the code inside of your effect depend on its plain props. So this code is like what you are injecting to be used here. It is so it must be declared and it is used here. So this is okay. This is the way of how now you take out of this code, out of the rendering calculation. You're going to now, so after React is rendering all of your components, or after React rendering, okay, generate is the VDOM, this new version of the VDOM, and then conciliate using the diffing algorithm and the Fiber, which is the reconciliation engine, and then apply the necessary DOM updates or sync with the DOM when you're gonna see your update screen. Now it's interesting. Now, yep. Okay. Now, now is when this code will be run. And when you're passed through the array of dependency, is something that now you're going to use inside of this. This is pretty much like your passing is the array of dependency that is going to be used here. Like this. The dependency array can contain multiple dependencies. React only React will only skip rerunning the effect if all of the dependency you specify has exactly the same values. And as they had during the previous render, React compare the dependency value using the object is. Determine whether the two values are the same. And this is now using the equality comparison and sameness. same value 0 equality. Strict equality, same value equality using object.is. Same value equality determine whether two values are functionally identical in all contexts. This use case demonstrates an instance of the list substitution principle, part of the solid. One's instance occurs when an attempt is made to mutate an immutable property. So you define property here, number -0, with the value variable configurable of that. You are defining is a type there, and function attempt mutation here. Object.define property number -0 with the value v. Object.define property will throw an exception when attempting to change an immutable property, but it does nothing if the actual change is requested. If v is -0, no change has been requested, and no error will be thrown. Internally, when an immutable property is redefined, the newly specified value is comparing against the current value using same value equality. Same value equality is provided by the object.is. It is used almost everywhere in the language where a value of equivalent identity is expected. So React compares the dependency value using the object.is. And the object.is is a static method to determine whether two values are the same. Same value equality determine whether two values are functionally identical in all contexts. One instance, functionally identical in all contexts. All instances occur when an attempt is made to mutate an immutable property. Notice that you can choose your dependency. You will get a lint error if the dependency you specify don't match what React expected based on the code inside your effect. This helps you catch many bugs in your code. If you don't want some code to rerun, edit the effect code itself to not need that dependency. This run amount, and also if either A or B changed since the last render. We'll take a close look at what mount means in the next step. Why was the ref omitted from the array of dependency? Because this is a secret pocket that we have. So React doesn't keep track of that. This is because ref has a stable identity. React guarantees you always get the same object with ref from the same it's because they have the same identity. Call on every render. It never changes, so it will never by itself cause the effects to rerun. Therefore, it does not matter whether you include it or not. Including is fine too. The set function returned by useState also have identity, so you will often see them omitted from the dependency too. If the linter lets you omit the dependency without errors, it is safe to do. Omitting always stable dependency only works when the linter can see that object is stable. For example, if a res was passed from a parent component, so you will have to specify it in the dependency array. However, this is good because you can now, whether the parent components always pass the same ref or passes one several ref conditionally, so your effect will depend on which ref is passed. And then you have the add cleanup if needed. Consider a different example. You are writing a chat room component that needs to connect to the chat servers. When it disappears, you are giving the create connection API that return an object with connect and disconnect method. How do you keep the component connected while it is displayed to the user? Start by writing the effect logic. How do you keep the component connected while it is displayed to the user? While it is displayed to the user, because you want to somehow run this function after rendering as a way to sync with that. So it will be starting by writing the effect logic. It will be slow to connect the chat after every rendering. Exactly, after every rendering it will be slow to connect that, so it is better to do this. Hey, the code inside of the effect does not use any props or state, so your dependency array is empty. This tells React to only run this code when the component mounts. It has appeared on the screen for the first time. Let's try and running this code. So when this code appears, I want you to now establish a connection. This effect only runs on mount, so you might expect connecting to be printed once in the console. However, if you check the console, connecting get print stripe. What does it happen? I think this is because from the static. Imagine the chat room component is part of a larger app with many different screens. The user starts their journey on the chat room page. The component mounts and calls connection connect. Then imagine the user navigates to another screen, for example, to the setting page. The chat room components on mount. Finally, the user clicks back to the chat mounts again. This will set up a second connection, but the first connection was never destroyed. Okay, that link was never destroyed. As the user navigates across the app, the connections will keep piling up. Exactly, because you're not releasing its memory here. Anytime you are connecting, you are not releasing the memory. Bugs like this are easy to miss without extensive manual testing. To help you spot them quickly in development, React mounts every component once immediately after it is initial mount. Seeing the connecting log twice helps you notice the real issue. Your code doesn't close the connection when the components are mounted. To fix this issue, return a cleanup function from your effect. This is a cleanup function. React will call your cleanup function each time before the effect runs again. Each time before the effect. Okay, each time the effect. Okay, so every time you run this code, this piece of code will now. Okay, the cleanup function will be called each time before the effect runs again, and one final time when the components are mounted. Okay, so when the component are mount, it will call this cleanup function, and also when the components or before each time the effects runs again. This is the correct behavior in development, because they're using is strict mode. By remounting your component, React verifies that navigating away and back will not break your code. There should be no user visible difference between running the effect once versus running it, cleaning up, and running again. There is an extra connect disconnect call pair because React is probing your code for bugs in development. This is normal. Don't try to make it go away. In production, you will only see connecting. Print once. Exactly. Remounting components only happens in development to help you find effects that need to clean up. You can turn restrict mode out of the development behavior, but we recommend keeping on. This lets you find many bugs like the one above. How to handle the effect firing twice in development. React intentionally remounts your components in development to find bugs like in the last example. The right question isn't how to run an effect once, but how to fix my effect so that it works after remounting. React intentionally remounts your component in development to find bugs. Okay. React intentionally remounts your component in development to find bugs like in the last example using the strict mode, which means that it runs your component, it runs your app to find common bugs, which means that it's gonna re-render an extra time, rerun effects an extra time, and be checked for using of deprecated API. Again, this will slow down the development process. Perhaps this is what you want or not, who knows? But this is just a provider or a context that they give it to you. How to handle the effect firing twice in development. Usually the answer is to implement the cleanup function. The cleanup function should stop or undo whatever the effect was doing. The rule of thumb is that the user shouldn't be able to distinguish between the effect running once, as in production, and a setup, cleanup, setup sequence as you see in development. Most of the effect you will write will fit into one of the common patterns below. Okay, don't use ref to prevent effect from firing. Okay, and this is now how to handle effect firing twice in development, and this is the pattern that we're gonna see that. Controlling non-react widget. How to handle the effect firing twice in development. Controlling non-react widgets. Subscribing to events. Triggering animations. Fetching data. Sending analytics. Okay. Not an effect, initializing the application. Buying a product. Exactly, because this is only code that is this is code that React calls when rendering itself after every commit phase, after every rendering, and putting it all together here. Mount the component, and then you got it. This is code that you want to run after that. Schedule text log. And after you mount that, you say clear that interval, and then you're gonna rerun with this state. And each render has its own effect. Holy moly. Okay. All right. That'll be all for this video. Take care. Bye-bye.